All right, so yesterday we talked about how to expand using the binomial theorem, right? So the first thing I want to ask of you today, and this one is, how many terms will there be in this expansion of this binomial?
6.
There will be 6 terms, exactly. How do you know that, Bobby?
Because it's an exponent plus 1.
It's always the exponent plus 1. So go ahead and set up your 6 terms. 1, 2, 3, 4, 5, and then 6. So set up your 6 terms. Here's the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. Okay, now, what else is important about this particular binomial? What do you see? It has a minus sign. So what does that mean? The signs are going to alternate. So the first one will be positive, second one will be negative, then positive, then negative, then positive, then negative. Sound good? Okay. Good. So then we're going to do our choosing part. So we're going to start with 5, choose 0. And then we go to 5, choose 1. And then 5, choose 2. And then 5, choose 3. 5, choose 4. And then finally, 5, choose 5. That's the first step that we do. After we have our choose down there, we take our x variable and we raise that to a power of 5, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and then finally x to the 0. And then we take our second term, which in this case is 2y, and we raise that to the 0 power, and then finally 2y to the 1st, 2y to the 2nd, 2y to the 3rd, 2y to the 4th, and then 2y, of course, to the 5th. What do you think the biggest mistake that students make on that step is? Ryan, what do you think it is, buddy?
Not putting a 2y in parentheses.
Yeah, they don't put the 2y in the parentheses, and therefore you forget to raise, like, for example, the 3, you only raise the y to the power of 3 versus the 2 to the power of 3. So this is what I call the setup phase, okay? Then the next thing you have to do is the cleanup phase. So once you've set everything up, you have to go through and now clean this up, okay? How much is 5 choose 0? Well, we know that's just a value of 1. What's x to the 5th times anything to the 0 power? That's just going to be x to the 5th. So our first term ends up being an x to the 5th. So this whole thing simplifies down to x to the 5th. Then I'm going to have a minus. 5 choose 1 is 5. I'm going to have x to the 4th and then 2y to the 1st power. Then I'm going to have 5 choose 2, which is how much, everybody? 10, right? According to Pascal's triangle, that's 10. And then x to the 3rd, and I'm going to have a 4y squared. What's 5 choose 3? 10. Also 10, so minus 10. X squared 2 to the 3rd is what, 8? 8y to the 3rd, good. 5 choose 4 is? 5, good. X to the 1st, 2 to the 4th, how much?
16.
Yep, 16y to the 4th. And then finally minus 5 choose 5 is 1. X to the 0 is 1. So I have 2y to the 5th. That'd be 32y to the 5th. Okay, now, is there anything left to clean up?
Yes.
This one, this one, this one, and that one, right? So when it's all said and done in black here, I get an x to the 5th minus, this looks like 10, x to the 4th y. This would be, what, 40? X cubed y squared. This would be 80 x squared y cubed. What's 5 times 16? 50 and 30? Is that 80? Yeah, 5 times 10 is 50, and then 30 more is 80, right? Okay. So 80 x y to the 4th, and then minus 32y to the 5th. And that would be our answer. What do you think? Okay, so let's say you're given x minus 3y, and you're expanding this to the 7th power. And we want to know the 4th term only. Okay, is there a way that we could maybe just figure out the 4th term without having to write all these out? Well, there is, right? Well, how many terms do we have total?
7.
Nope. We'll have 8 terms total. So I'll go 1, 2, 3, 4, 5. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, all the way out to, I would have A sub, I'd have 8 terms total, right? Because it's a minus sign, I'm going to have, this is going to be negative, this is going to be positive, this is going to be negative, this is going to be positive. The one that I want is right here. That's the one that I want. Okay?
Wait, do you start with the negative?
Oh, sorry. Positive. Yikes. Thanks a lot.
Like arbitrary or
No. You're totally right.
something.
I was off there by 1. So positive, then negative. There we go. So our answer will have a negative in front of it. Thank you so much. Okay, let's see here. When we build this thing, right, we were building and we started with a 7, choose 0, right? And then we had an x to the 7th and then a 3y to the 0. Okay. Then we had a 7 to choose 1. Then we had an x to the 6th and then a 3y to the 1st. Okay, now, you guys notice that these two numbers always add to that, right? And you'll notice that this number is always matching with that number there, which is always 1 less than that number there. So therefore, if we want this term, it's going to be 7 choose what? No. 7 choose 3, x to the power of something, and 3y to the power of something. Well, if this is a 3 down here, then this has to be a 3 up here, right? And 3 and what makes 7? So that has to be a 4. So we want to compute this value. So what is 7 choose 3? Well, we can use Pascal's triangle or we can use our calculator. So I'll go 7 math choose 3, and I'm getting 35. So this is going to be 35 x to the 4th, 3 y to the 3rd. Now, what's 3 to the 3rd? 3 times 3 is 9, 27. So I'm going to have 35 times x to the 4th times 27 y to the 3rd. Now, what's 35 times 27? Anybody figured it out yet?
945.
Yeah, I think you're right. 35 times 27. Whoops. Sorry. Times the 27. Got 945 out of that? Yep, there it is right there. So we're looking at a negative 945 x to the 4th, y to the 3rd. And that's how we can skip up and find any term in the binomial that we want.